Hey guys, welcome to AlgoYogi, and today we will be solving diameter of binary tree. Let's go to the LeetCode problem. And the description says, given the root of a binary tree, return the length of the diameter of that tree. Now, the diameter of a binary tree is defined as the length of the longest path between any two nodes in a tree, and this path may not pass through the root. And the length of the path between the node is represented by the number of edges between them. So we know it's talking about the height, right? Not the depth, like the last question, height, counting the edges. Let's switch our view here and see how we will be finding it. So given this example, this particular example, what will be the diameter here? So if we follow the definition here, it's basically asking the longest path between any of these leaves. So leaf to leaf. So what are the paths from leaf to leaf here? So go to 5, and given that we are not repeating the nodes in somewhere in between that path. So one path will be going from this leaf through the root to 3. So this will be number of edges here are 3. This edge, and this edge. Okay. Now there is one more here, which is this one, which is 2. Now, so the diameter of this one will be, what is the maximum of these two? It's 3, right? The answer here will be 3. Now, how we gonna approach this problem is basically making use of the height algorithm, like height problem. We haven't solved it yet, but we will solve it right now. So in order to find the diameter of any binary tree, what we are really doing is we are at every single root or node, we're basically asking what is your left height and what is your right height, and the diameter would be just adding both of them. That's it. So now it's very simple to think about. So although it seemed complicated, oh my god, like from this leaf it's going from this leaf to this leaf, how are we going to calculate that? But if you're standing right here, my guy, I was trying to make a smiley, but I don't know why I made. But if you're standing right here, and then you say, like using a recursive function, can you give me the height, child? This one, it's gonna ask this one, can you give me the height, your height? And then it's gonna ask the right one, give me the height of the right subtree. So this will basically ask its kids. This will return 1, this will return 1, maximum out of these is 2, and this will return 1. So then now at this point, it can just simply add these, and then return the diameter. But always remember, this doesn't have to pass through the root. The diameter doesn't always have to pass through the root. So at every node, we will be updating our diameter. We will make it a global variable, and then we will update it at every node. So because every node will be calculating left and right height, so we can update at every point that the diameter would be the maximum of the previous diameter or left and right height. Simple, right? And the reason I'm saying it doesn't have to pass through the root is, let's say if we had this one, and basically let's say now I would keep just increasing these and increasing these. I'm just repeating these numbers, but like let's just don't focus on the number, just focus on what I'm trying to say. So this one, this is not the maximum left and right sum, left height and right height sum, it will be this one. That's why. So I just simply wanted to depict that. It has no use. We have already understood the algorithm, and let's just write our solution now. Okay, let me switch the view here. Okay, let's come back to LeetCode and implement our solution. Let me zoom here. We'll have our diameter, as we talked about, as just a reference variable. Like, so I'm making it an array, like one index array, so that it can be accessed inside our inner function. Let's create our inner function, which would be creating height function, not the diameter, but we will be updating the diameter. Just remember, let's not get confused between, because this function will be finding, okay, I'm just not height find, but find height. It will be finding the height of root, although we don't have any use of returning the height, but finding the height, adding them makes the diameter, and we will return the maximum diameter. I mean, diameter is the maximum left height and right height. Okay, so just like height is processed, is if root is none, sorry, I don't know why I'm so excited to type and typing nothing. We return -1. Left height basically is find height on the root dot left +1, because we're calling it from a proper node, right? And right height, because height of the root node, if it has a value, it's not empty, then it is 0. And when it's calling on left and right, it's basically getting -1 from each side, but it wants to return 0, so we're adding 1 over here. I think that's self-explanatory because it's easy. Now root dot right +1. Now what I want to do, I want to return the height, which is maximum of left and right. We already added 1, so we don't have to do anything over here. You know, we have added to both of them, and the reason I'm adding it here is so that I can also update my diameter, you know, from left and right, and already the root value added. So the diameter, it's the 0th index, would be maximum of diameter. Oh no, it's not. Oh my god, sorry, sometimes things happen. Okay, don't judge, just observe. Okay, and here either the previous diameter or it's, sorry, my keyboard is just messing up. I should have just typed everything rather than copying. That makes things, you know, harder. But okay, now we will basically call this function on our root, and calling on our root and then returning our diameter 0th value. Okay, so I think this is very clear, what we talked about. And if we run it, then we should be able to, let me zoom out, and it's getting, indent does not match any outer. Why not, brother? Why not? Because it does match. It does match. What are you talking about? Now Oh my god. Oh, this indentation. That is stupid. It's talking about this indentation. And this indentation. Is it with everything then? Did I fuck up? No, this is good. Okay, sorry. I did not fuck up, but let's submit it. Running our example. I think it was very clear. We already talked in the conceptual part. What we are actually doing, we're just writing the solution. We're just translating our thoughts to the code. And it's easy. It's rather easy, right? Okay. And last thing is time complexity is big of n. That's the number of nodes, and that many times we are visiting each node just once and calculating its left and right height. Now space complexity would be big O of h. H is the height. Okay, at that like implicit stack, that many times we are placing the height, and height will always be less than the number of nodes. So be specific that you're, in worst case, honestly, in worst case it would be n. Sometimes h could be equal to n, right? And we can call it n because what if the binary tree only has just left, or right, then it's just the length will be equal to the node, or one less, or whatever, right? One less, of course, because that's the number of edges will be, number of edges are one less than the number of nodes. Okay, done here. Let's go back to our AlgoYogi and mark this problem solved. Hey, see, it's tracking the how much trees we have solved and how much total problems we have solved. And okay, bye bye, see you in the next video.